Hello everyone, welcome to my YouTube channel. So basically, econometrics is a course which is taught at undergraduate level in universities, and mostly it is considered a little bit, sometimes students feel that it is a little bit difficult. So in lecture series of basic econometrics, which I'm starting, in this I'll just discuss econometrics in a very simple way, the regression. What basically sometimes it happens like that, you know how to estimate it, but when the concept behind the t-test or f-test or things like that, so mostly students have no idea about it. So basically in this lecture series we will deal with regression, multiple regression, and then there are certain assumptions which are associated with the linear regression model when we are applying the OLS or the least square. Of course, these sums right now will it's just new, but as you will move in towards the different lectures, you will understand that so what is multicolority, what is heteroscedasticity, what is autocorrelation, and what are the different tests to perform it. And moreover, I'll deal with the greater software. So in today's video, I'll just start with the basic because we'll just move step by step. So in this video, I'll just tell what about the dependent and independent variables with certain examples. And through gretl software, I'll also tell you how can you use the sample files in order to see those variations. So today I'll just stick to the dependent independent variables and a little bit discussion about the multiple regression. And in my next lectures, then I'll move towards the interpretation of results and the stuff like that. Okay, to start with, we have this equation: y is equal to alpha plus beta x plus error term. Okay, so over here, y is the dependent variable, x is your independent variable. We can also call it explanatory variable or regressor. And your beta, the coefficient, we can say beta, or when I'll move towards the multiple regression, we will have beta 1 or beta 2, or you can name it anything. So basically beta is telling you the effect of change in your dependent variable, due to 1 unit increase in your independent variable, which is x over here. So whenever you will take the sample and put your data in the, like I'll be using the gretl software or any software, you will get this coefficient which will tell you that what is the change in your dependent variable due to the 1 unit increase in your independent variable, or due to one independent variable, or you can call it explanatory variable, error term, or residual. For the sample, whenever you take a sample from the population, you call it a residual, and for the population we use the term error. So error term contains all the factors other than x, all factors other than your independent variable which you have taken in your equation, all factors other than your like in this case we can say all factors other than x which can affect your y, which can affect your dependent variable. Of course, it's just not like that that like your independent variable will just be, the change will be just due to x. There will be other factors which will be affecting it. So error term includes all the other factors which can affect your y. So beta is telling you the effect of 1 unit increase in x on y. Now just taking an example, for example, we know that from the theoretical background that consumption is a function of income. Like income has two parts, one is consumption and one is saving. So if we want to see the effect, so the equation can be C is equal to, C denotes your consumption, plus beta y plus your error term. So here C is your dependent variable
I'm just denoting it by D. Y is your independent variable, and you want to see the effect of income on the consumption. And your consumption just not only depends on your income, there are the other factors, which is the error term. So this is basically the equation that you want to see, you want to check what is the effect. So beta value will tell you the change in consumption due to 1 unit increase in your income. Now, for instance, if your beta values come to be 0.8, you are measuring in dollars. So you can say $1 increase in your income, $1 increase in your income has increased your consumption by $0.8. So this is how you can interpret the coefficients. And when I move towards the gretl software, basically I'm just telling you that how you can formulate an equation, a regression equation. In econometrics, we use the term error, and this is the way we write the equation. And when you estimate it, and first of all, I'm just keeping it simple right now, because there are many things involved in it, which we will which I will be telling you step by step in every lecture, because in every lecture we'll be moving a little bit ahead. So here I'll be using ordinary least square method. Now, ordinary least square method is a method which is used to measure these beta values. So whenever in the software I use the ordinary least square, there are certain assumptions which are associated with the ordinary least square, like there should be no multicollinearity or no autocorrelation, whatever. What is multicollinearity, what is autocorrelation, I'll have a separate lecture for that. But right now you must know that in ordinary least square, the assumptions are being followed, then you get the best estimates. So why you need the best estimates? Okay, of course, if you want to know the effect of you want to know this beta value, you want this consumption, your dependent variable, to be as close to your original value. So estimated, if I in the original equation I use y as a dependent variable, so it is y is equal to alpha plus beta x plus your error term. So y hat, the estimated y hat is denoted by the estimated value. So the difference, this is your estimated one, the difference between the original value and the estimated one, like y minus y bar, this is your error term, it's your residual, the error term of your residual, what is the difference between your real and the estimated value. And what is the goal of regression? You want is to be the minimum, the difference should be minimum. You want your estimated value to be as close to the real one. So for that you use the OLS, which is the method which minimizes this difference, sum of square of the residuals. Now of course, when we will deal with the assumptions, you will know about it, at what are the assumptions which are being followed by the OLS and whatsoever. But right now I'm just making it simple. So first of all, you understand the basic things, the basic equation, or how can you, if you have an equation, how can you interpret it, what are the beta values, what is the dependent or independent variables. Now see, if I say wage is a function of education, if I beta 1 plus beta 2 experience plus beta 3 gender. So basically now this is called multiple regression. So first of all, just understand the difference between the linear regression, what is this difference between multiple regression. It's just in multiple regression you have more than one variable, independent variable or explanatory. Here we have 3 explanatory variables or independent variables. Now here we want to see the effect. Beta 1 tells you the effect of education on wage. like of course we will, if you are taking like number of years, so you can say that by increasing the number of years by 1 year, by the school years by 1 year, how, what is the change in your wage, that beta 1 is telling you, but it is holding the other two variables constant while calculating this one. So beta 1 tells you the effect of 1 unit increase in your education on wage by keeping the other factors constant. On the other hand, experience beta 2 tells you the effect of increase in your experience on your wage by keeping all the other factors constant. And beta 3 tells you that the effect of gender on your wage by keeping your other variables constant. Gender, when we take gender, it is dummy variable. In dummy variable like male or female, I'm not, we will get into the details. There will be a separate lecture for that in which I'll consider that what is the dummy variable and how to, but right now in this lecture I'm just concentrating on the simple things like what is the dependent, and in the gretl software also I'll just be doing the simple things like how you, what is the beta and beta 2 values. I'm not going to do the R square just right now, just telling you the simple. So in this way you can make as many, like if you want to see the effect of GDP on the economic growth, so you can take the variables, your dependent independent variables, how you will measure your GDP by GDP per capita, or any other, or how you will measure your economic growth by GDP per capita, what are the variables that you are taking for that. So this you must know that what how you will formulate it and what is an econometric equation basically. And then in the next slide I'll be moving to the gretl software. Okay, so now we will move towards the gretl software. It's an open source, you can download the software. So there are many sample files in it. You can also add the data in the gretl software, but today I'll just tell you how to deal with the sample files. So in the sample file, like if I'm taking this data model, I just mentioned that we use OLS. So from model you will just click ordinary least square method, and here you have to give your dependent and independent variables. Independent variables are also called regressors and explanatory variables. So real GDP you're adding here. If I want to see the effect of population on real GDP, if I want to see the effect of unemployment on real GDP, I'll take like this. If you want to remove any, you can just remove it by clicking it. Otherwise just include these two by clicking OK. You will just get this result. There are many things given here, but I'll just see I'll just stick to the things that we have done in this lecture. Like basically populate this coefficient. So 60.6, this is telling you that 1 million increase in the population, as population is given in millions, 1 million increase in the population will increase your real GDP by $60.71 billions, which is your real GDP. On the other hand, with a 1% increase in the unemployment, your real GDP will decrease by $175 billion. So this is the interpretation of this coefficient that I was discussing, that 1%, that the beta tells you the change in your dependent variable due to 1 unit increase in your independent variable. Now what these p-values, t-ratio, that I will discuss in the next lecture. First of all, I will tell you what is the p-value all about. So if you want to take any other, like in any other sample file, and then you must know that there is a difference between the time series and cross section. You can see over here, time series data is that you a number of years or number of months the data given over there, and cross section at just one time which the data is given to you, that is called cross sectional data. So on the other hand, if I just want to see like house prices is, and this is this cross sectional data, so just click yes. Now if I want to see the effect of the area on the price of the houses, so I can just, this is the dependent variable, this is the independent variable, you just click OK. You get this observation which is telling you that if you increase the area of the house, if you increase that by 1 square foot, your price will increase by 0.138 thousands of dollars. So this is the interpretation for the beta values. Similarly, you can use any sample files, and you can you just have to add your dependent and independent variables, and the data will be, and the result will just come by just one click. And moreover, if you want to you have your own data and you want to add the data, you can also do that through the gretl software, and that I will discuss in any of my next videos.
Okay, so this was all about today's video. I have tried to keep it as simple as I can, because just the understanding in econometrics is just step-by-step understanding of the facts and the figures. It's just not yet you will be just trained in one day, and but still I have used the software, and you can use the sample files and stuff like that, because gretl software is very easy to use. So even if you want to if you know other things but you just want to use the software, so these lectures will also help you in understanding how can you use the gretl software regarding the regression, regarding how you just to test different things like autocorrelation, like multicollinearity test. So everything is over there, but I moved step by step. Hope you like the video. Thank you for watching it.